On the night of August 27th, billions of people are going to look up and watch the moon almost disappear. Not behind clouds, not behind buildings, behind the shadow of an entire planet. Earth is going to slide directly between the sun and the moon, and for a few hours, our own shadow will creep across the lunar surface until it swallows 96% of it. What's left behind won't be white. It won't be gray. It will turn a deep, burning red, as if the moon itself were on fire. And here's the part almost no one expects. It isn't fire, it isn't dust, and it isn't an illusion. It's sunlight, bent through the edges of our own atmosphere, painted onto the surface of another world. This is one of the last great skywatching events of the year. And to understand why the moon is about to turn red, you first have to understand what's actually happening 240,000 miles above your head. Every eclipse starts with a simple, almost mechanical alignment. The sun, the earth, the moon. Three bodies briefly falling into a straight line. When the moon passes between the sun and earth, we call that a solar eclipse. The moon's shadow falls on us. But on August 27th and into the early hours of August 28th, the alignment flips. The earth moves between the sun and the moon. Our planet's shadow stretches out into space, and the moon drifts directly into it. This is a lunar eclipse, and this particular one is unusually dramatic. Astronomers are calling it a deep partial eclipse because at its peak, more than 96% of the moon will be swallowed by Earth's darkest shadow. Only a thin, glowing sliver near the lunar north will remain untouched, lit directly by the sun. It's so deep, so close to total, that some are already nicknaming it an almost blood moon. For observers across North America, South America, Europe, Africa, and parts of Western Asia, this will be one of the most striking lunar eclipses in years, and astronomers say it's the best one we'll see until New Year's Eve of 2028. But there's a detail here that trips people up almost every time. If Earth is blocking the sunlight, why doesn't the moon just go completely black? This is where things get strange and where the real science begins. You'd expect that once the moon slides into Earth's shadow, it should vanish into total darkness. No direct sunlight reaching it. No light, no color, nothing. But that's not what happens. And the reason comes down to something most people never think about. Earth doesn't have a hard, clean edge in space. It has an atmosphere, a thin shell of air wrapped around the entire planet. As sunlight travels toward Earth, some of it grazes the edge of our atmosphere. Instead of hitting the planet directly, that atmosphere acts like a filter, similar to a prism bending light. Shorter wavelengths of light blues and violets get scattered away in all directions. It's the same effect that makes our sky blue during the day. But longer wavelengths, reds and oranges, pass through more easily. They bend around the curve of the Earth, like light traveling through the edge of a lens, and get focused directly onto the surface of the moon. In other words, every sunrise and every sunset happening on Earth at that exact moment is being projected, all at once, onto the lunar surface, 240,000 miles away. That's not a metaphor. That's the actual physical mechanism. You are looking at the combined light of every sunrise and sunset on Earth, reflected back to you from the surface of another world. The deeper the moon sits inside Earth's shadow, the more of that filtered reddish light dominates, and the deeper red the eclipse appears. But here's a detail that separates this eclipse from a true blood moon, and it matters. A total lunar eclipse happens when the entire moon slips into Earth's umbra, the darkest part of our shadow, cover to cover. When that happens, the whole lunar disk can glow that deep copper red color at once. This event on August 27th and 28th is different. It's a deep partial eclipse. At its peak, roughly 12:12 a.m. Eastern Time, on August 28th, about 96% of the moon will fall inside Earth's umbra. That remaining sliver, just a few percent of the lunar disk, will stay in direct sunlight, a bright, blazing crescent sitting right beside a surface turned the color of rust. It's a strange, almost unsettling sight. Most of the moon glowing dim and red, while one edge still burns bright white, like a spotlight refusing to switch off. And there's another layer to this story that connects it to timing most people wouldn't think to check. This eclipse is happening just days after the moon reached apogee, the farthest point in its orbit from Earth. That means the moon will appear at roughly its average size in the sky, not unusually large or small. But it also means it's moving a little slower along its orbital path, which can slightly stretch out how long the eclipse phases last. Every eclipse tells you something about the mechanics of the solar system if you know where to look. This one is telling us about geometry, distance, and timing, all lining up on a single night. Here's the fact that turns this from an interesting sky event into something genuinely rare. According to astronomers tracking the eclipse, this deep, partial lunar eclipse will be visible, at least in part, to roughly 3.3 billion people across the planet, nearly half of humanity, all looking up at the same shadow, crossing the same moon, at the same moment in time. For observers across the eastern United States, the timing lines up almost perfectly with a clear night sky moment. The moon will rise already partially inside Earth's shadow, climbing into view already, turning that deep, coppery red. You won't need a telescope, you won't need special glasses, the way you would for a solar eclipse. A lunar eclipse is completely safe to watch with nothing but your own eyes, because you're not looking at the sun. You're looking at reflected, filtered sunlight, gently bent around an entire planet. And here's the detail that makes it land differently once you understand the mechanism behind it. That reddish glow crossing the moon isn't a special effect created for this event. It's the same physical process that colors every sunrise and sunset on Earth, just relocated for one night onto another world. Every time you've watched a red sunset from your own backyard, you were watching a smaller, closer version of exactly what will paint the moon red on August 27th. The moon isn't producing that color. Earth is projecting it. The core mechanics of this eclipse are extremely well understood. Lunar eclipses have been predicted with remarkable precision for centuries, using orbital calculations that account for the exact motions of the Earth, moon, and sun. Astronomers know down to the minute when the eclipse begins, when it peaks, and when it ends. They know precisely how much of the moon will be covered and roughly what shade of red to expect based on models of Earth's atmosphere. But that final detail, the exact color and brightness of the eclipse, isn't perfectly predictable in advance. The precise hue of a lunar eclipse depends on the condition of Earth's atmosphere at that moment. How much dust, cloud cover, volcanic ash, or pollution is suspended in the air along the edges of the planet, subtly bending and filtering the light. That means every lunar eclipse looks at least a little different. Some appear a deep brick red, others glow a lighter copper or orange. It's one of the few celestial events where atmospheric science on Earth directly shapes what you see happening on another world in real time. So, on the night of August 27th, when you look up and see the moon fading into red, understand what you're really witnessing. You're not looking at a moon that's changed. You're looking at the shadow of your own planet, stretched across 250,000 miles of space, carrying the color of every sunrise and sunset happening on Earth at that exact instant. For a few hours, the moon becomes a mirror, not for light, but for the atmosphere we breathe every single day. Billions of people on one night will look up at the same sky and see the Earth's own horizon reflected back at them from another world. That's not a coincidence of orbits. That's the solar system, quietly reminding you that you're standing on a planet with an atmosphere thin enough to bend light and just far enough from the moon to paint it red once every few years.